In lesson 7, we are going to look at applying ratios in right triangles. We're going to solve some problems using right triangles and trigonometry. So go ahead and try this problem. It's on page 165 in your book. Along the side, I've put your reference chart items here, reminding you of cosine, sine, and tangent. So go ahead, calculate the length of these two legs, pause the video, and come back. So first things first that you want to make sure that you're remembering to do is find the angle, that acute angle that you're using. So in this case, it's 20. That one is going, I mean, you could use this one too if you wanted to label this. So if you wanted to subtract 20 from 90, you could figure out that this one's 70 and then use that one. You're welcome to do that. But determine which angle you're going to use and then label the sides accordingly. So directly across from that angle is going to be considered the opposite side. Okay, so I'm just going to call that X. And then right next to that side is the adjacent. So I'm just going to call that Y, and this is the adjacent side. And across from the 90 is always the hypotenuse. So the 6 would be your hypotenuse. So then you can decide what you're going to solve for first. Okay, do you want to solve for X or do you want to solve for Y? So I'm going to solve for X first. So X is the opposite side and I have the hypotenuse. So I look for those two words, opposite and hypotenuse, and I see it here in the sine function. So we're going to set up a sine function. So sine of the angle, and your angle is 20, equals the opposite side, which is X, divided by the hypotenuse, which is 6. So then you're going to plug sine of 20 into your calculator, and you're going to end up with a decimal point 342 equals X over 6. So then you'll be able to cross multiply here. Okay, so multiply that 6 up, and you'll end up with 2.05 equal to X. So if you wanted to round to the nearest tenth, that would be 2.1 for side AC. Then you can go ahead and find BC. Now again, there's going to be two options for this. So you could do Pythagorean theorem. Okay, so if you want to do Pythagorean theorem, now that you know that this side is 2.1, you could certainly do that. It's going to be rounded. Okay, so it is going to be a rounded answer. Your more exact way to do it would be with the trig. Okay, but either way is fine. So if you're doing Pythagorean theorem, you'd have the hypotenuse squared equals the legs squared and added together. So you could solve that way. Since the trig is new, I'm going to do the trig version. Okay, so again, you can do this, that's fine. For using trig, I'm going to do the adjacent side is what I'm looking for, and I'm going to use the hypotenuse since they gave me that at 6. So now I'm looking for adjacent and hypotenuse, and that's the cosine function. So cosine of your angle, so cosine of 20 equals the adjacent side Y over the hypotenuse 6. So figure out cosine of 20 using your calculator, and you get 0.9397 equals Y over 6. So then cross multiply. So multiply 6 to that decimal, and you'll get 5.6. So if you did the Pythagorean theorem, you would have been close to that as well, but there's your AC and your BC. All right, so let's take a look at what do we need in order to be solving or finding the lengths of two legs of a right triangle, okay? What is the information that we actually need? And so in order to do this, so what we've been doing is taking a look here. It would be nice to know the name of the triangle. We can kind of see that if we're looking for side AB and side BC, we see the 3 letters there. Okay, so we probably already knew that the triangle's name was ABC. We probably need to know what the right angle is. Okay, so we've been using a bunch of right triangles now. So it would be nice to know which one is the 90-degree angle, because that would help us with some other information. So in this case, in order to label it, we know this one is going to be labeled C. Probably want to know some other angles. So in this case, it says angle A. So we'll just label angle A and write in the degree measure is 42. Okay, so what else would we need to know? So this just gives us some angles. Now we know this triangle could be any size. So we probably need some length that would set how big the triangle is. Okay, so in this case, they tell us that AC is 4 centimeters. So the length of that side is 4 centimeters. We would know the B was here. Okay, and then this one also says that AB is the hypotenuse. Okay, so we can see that here. Okay, across from angle C. So if you already know the right angle, you don't actually need to know which one the hypotenuse is, because certainly directly across from the right angle is the hypotenuse. So if C is the hypotenuse, the other two letters create, or sorry, if C is the right angle, the other two letters create that hypotenuse. So you wouldn't have to be explicitly told that. Just like if our problem says find these two sides, we already know the 3 letters of the triangle. But then this would be enough to come up with those other lengths, because then you've got an angle, you can label the sides. So we've got that hypotenuse. We know that the given side is the adjacent side in this case. And then BC is the opposite side that we're looking for. So then we could set up a couple of trig functions in order to solve that. So let's take a look at another one. Okay, so again, in this one, they're already kind of telling us the letters of the triangle. So we see that we've got an E, an F, and a D. Okay, so the triangle uses those 3 letters. So we wouldn't have to necessarily ask for the name of the triangle. We already know that. We're using right triangles. So we know that we have a right triangle. So when we go to draw it, okay, we can draw one with a right angle. We do need to know which letter goes with the right angle. Okay, so letter E is the right angle. Then we would need to know, an angle measurement. Okay, another acute angle measurement. So we know what trig function to do. Okay, we know what this triangle is similar to, either looking in our right triangle table or using our calculator. And then we would also, so then the hypotenuse is DF, okay? So F here, first that 71 I should have labeled, and then D. Again, this is kind of unnecessary. We don't necessarily need this or this. Okay, this one because it was kind of given to us, and this one because it just will be across from the 90 will definitely be the hypotenuse. Okay, so we wouldn't necessarily have to ask or get that information. But we do need a side length. Okay, so you need to set the measurement. So we need to know how big one of the sides are. So in this case, we've got that 71-degree angle. Okay, next to the 71-degree angle is the adjacent side. So FE is the adjacent side in this case. Across from the 71-degree angle is the opposite. So this would help us set up a couple functions to solve. So definitely need to know that it's a right triangle with one angle. Okay, so you need to know one of the angles and one of the sides in the right triangle. Once you know that, you should have enough to solve. So let's take a look at using trig in some real world buildings. Okay, so there's this building called the Burj Khalifa in Dubai. So here's where Dubai is, okay, on a map. And so this is the tallest building in the world as of April 2019. Okay, so the tallest building in the world is located in Dubai. So this is saying if you're standing on a bridge that's 250 meters from the bottom of the building, okay? So here's you at point C, the bottom of the building, you're 250 meters away. You have to look up, okay? So you look up at a 73-degree angle to the top of the building. How tall is the building? Okay, explain or show your reasoning. So we've got this right triangle here. Let me actually get a real right triangle. And you can see it over here in the picture. Okay, so we've got this right triangle here. And we've got some measurements labeled. Okay, so we see that we know two angles just like we needed, right? So we've got the 90-degree angle and we've got this 73-degree angle. We also see that we know one of the sides. And then we're looking for the height of the building, how tall that building is. So we should be able to, in this case, set up a trig function. So we know that the 250 is next to the angle. So this is our adjacent side. And then the height is across from the angle. I don't know why it's not changing color here. All right. Guess it doesn't feel like changing color. Maybe it's this. Oh, there we go. Okay. And then across from the angle is the opposite. So across from the 73, or the height in this case, is our opposite. So the function that sets together the opposite and the adjacent, and you can look in your reference chart, is tangent of theta equals the opposite side divided by the adjacent side. So we would do tangent of the angle, so 73 in this case. The opposite side is x. The adjacent side is 250. Remembering that tangent of 73 is just a value from your calculator. Okay, so do tangent of 73. And you should get 3.271 equals x over 250. So you can cross multiply this. So this is like a proportion. So we can just multiply that 250 up. When we multiply the 1 up, it doesn't change the x. So 3.271 times 250 gives us that x equals 817.8. And then we were in meters. So this is an approximate height of the Burj Khalifa. 817 meters. So let's take a look at the tallest masonry building. Okay, so a masonry building. So if you look here, masonry, it just consists of building structures from brick and mortar, okay, or concrete blocks or stone. So brick in this case, okay. So the tallest masonry building is in Philadelphia. Okay, so Philadelphia, Pennsylvania in the United States, located here. So let's take a look at figuring out how tall that building is. Okay, so we'll do a similar thing to what we did for the Burj Khalifa. So let me get a right triangle drawn here. And so now this is telling us if we're standing 1,300 feet, okay, so 1,300 feet from the base of the building, okay, so 1,300 feet from the base of the building. So here's where we're standing. Here's the building, right? So we're 1,300 feet from the base of the building. And we look up at a 23-degree angle. So if we look up at a 23-degree angle, we'll see the top of this building. How tall is the building? So again, we've got the side next to the angle. Okay, so next to us is the adjacent side. Across from where we measured this angle is the opposite side. The function that puts together the opposite and the adjacent is, again, the tangent function, and it does opposite divided by adjacent. So tangent of 23 is equal to x over 1300. Figure out tangent of 23 in your calculator, and you get 0.4245 equals x over 1300. So solve that proportion by multiplying that 1300 up. And we get x, or the height of the building, equals 551.85. And remember, this one was measured in feet. So that's the height of this building in feet. So if you wanted to round to the nearest foot, you could say 552 feet. Okay, so that's how we can estimate the height using how far we are from the building and looking upwards at it and measuring that angle. So the actual measurements here are 829.8. So remember, we got 817.8. Okay, so we got 817.8, and then 548, and we got 552 from our calculations. So why don't they match? Because we estimated in there. So estimating how far you're actually standing versus exactly how far you're standing. So this looks to be rounded, 250, rounded to the nearest 10 meters. Okay, something like that. When you're talking such a tall building, any amount of rounding is going to be significant. Okay, so 252, 247, those are going to produce some significantly different numbers. We also round here in the tangent decimal. Okay, so we rounded in the tangent decimal. Again, that's going to give us some different answers. Rounding here in the angle, maybe it was 73.1 degrees, or maybe it was 72.7 degrees. Okay, all of those are going to produce different answers. Okay, same for the City Hall in Philadelphia. Okay, so we had a lot of rounding. So we're still coming up with estimates. They're reasonable estimates. Okay, they're pretty close. Okay, when you're talking 830 meters versus 820 meters, that's pretty close. Okay, for an estimate of a height. So is it reasonable to assume that you're accurate to the nearest tenth in this case? No, because we're rounding. Okay, so we're rounding the measurements. So we're saying it's approximately these values. So approximately, not actual measurements if we were to go and take a huge measuring tape and measure that. All right, so the lesson synthesis, so kind of combining everything we learned. So in addition to measuring the heights of objects that are too tall to reach, professionals do use trigonometry to calculate heights of objects that they're designing. Okay, so here's some different things, some information that a billboard designer would need to know about a new site. So thinking about the local law that states the maximum height that a billboard can be. Thinking about how many degrees a person needs to look up to see over the trees as they're driving so that they would actually see their sign. Okay, and how far the highway is from the billboard. Okay, so you're kind of thinking about, here's the car driving, okay, down the road. How high are the trees? Okay, so that you can actually see this billboard, but the billboard can't be more than 50 feet above the ground. Okay, thinking about how far this billboard is away from the road. Okay, so 47 feet in this case from the road in order for the driver to see over this tree. Then they have to be looking at a 40-degree angle. Okay, so thinking about, because it just can't be more than that. So then thinking how high this billboard needs to be between, when they see over the tree. So you could calculate that information to figure out how low the bottom of the billboard would be. Lesson summary. So we're using, today we looked at using trig to come up with some indirect measurements. So like you wouldn't have a ruler high enough to measure a tree. So you can measure out how far you're standing away. Think about the angle that your eyeballs move to look up at the top, and you could estimate, come up with a reasonable estimate of the height of that tree. Knowing that we've got this angle, we've got the adjacent side. Okay, so we can measure how far we are to the object, which is the adjacent side. Then the height of that object would be opposite of our angle. So we'd be setting up a tangent function in order to come up with an estimate of that height. Now, is it exact? No, but it's a pretty reasonable guess.